All right. Last we met, we talked about how you're going to tell linear functions from nonlinear functions, right? And one of the things we said is when we're given a linear function, we're given it as a table of values, what we can do is we can compare the slopes, right? We said that linear functions always have the same slope. So if I look at my change in y as compared to my change in x, um, it will always be the same. Now, for all of our examples today, we are going to have x values that are going up by 1. So we're not really so concerned about that today. What we're really focused on is the change in the y values, okay? So they're all going to have a change of 1. If it gets any more complicated than that, we'll take a look at that. But for right now, all your x values are going to change by 1. So let's take a look at what a linear function would look like. Well, if we take a look, if we take the number and subtract from it the number before it, so what's 9 minus 5? Well, that's 4, right? So this means this is a change in 4. What's 13 minus 9? Well, it's a change of 4. 17 minus 3, 4. And 21 minus 7 is going to be 4, right? So these you could just look at and say, hey, how do I get to the next numbers? Plus 4, plus 4, plus 4, plus 4. But if you're a little bit stuck, you can always subtract, okay? So when it's linear, you're always going to have that same change. It's a constant slope, right? For something that's quadratic, let's take a look. What's my change here? Well, 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4 is going to be 5. And 16 minus 9 is going to be 7. So again, it's a pattern, right? But if you notice, these are all changing by the same amount. These are changing by a different amount. And if you want, you could probably find out the difference. Well, if you noticed, what would the next number be? If I went to 5, that's 1, 3, 5, 7. Well, the next number should be 9 more. Okay, so if I plug in plus 9, right? 16 plus 9 should be 25. So there is a pattern here, but it's not that constant slope we're looking for. Now let's take a look at exponential functions. Now, again, if you guys forgot, this is like y is equal to 2 to the x power, okay? And quadratics are something like y is equal to x squared. So it's a base squared, and this one you have a base of 2 raised to an exponent. It doesn't have to be 2, but 2 is the most simple example. So let's take a look. Here I have a change of 1. Here I have a change of 2, right? So again, right here, not quite enough to really say something like that, but if I do the next one, then I have a change of 4. Now I have a change of 8, okay? So again, if you wanted to, if you're good at numbers, you can actually probably see the pattern here and be like, all right, well, 1 squared is 2, 2 squared is 4, 4 squared is 8, the next number should be plus 16. But the big thing is that we want to be able to tell these from a table. So if it's linear, it's going to have this constant change. I will say this, though, if it's quadratic, these numbers will have a constant change. How do I get from each level to each level? It's 2. Okay? And these don't have that. Okay? So what we're really going to be looking for from a table is, hey, first of all, is it linear? So is the growth rate constant? If it is, then it's linear. If not, then we have to check the secondary set of numbers. The secondary set of numbers, we're looking for that constant change. If that set of numbers is the same, then it's quadratic. If not, it's going to be exponential. Okay? So let's take a look at a couple examples to see if we can't figure this out. Okay? So here, again, all your x values are going up by 1. So what's your change here? So in other words, first of all, if you're not real sure about things, guys, break out the calculator and go, hey, what's negative 45 minus negative 15? That's all you have to do is subtract. Okay, so subtract the bigger number, well, not the bigger, the next number minus this number. Okay, and what are you going to get? You're going to get negative 30. Okay, negative 135 minus negative 45. Okay, so negative 90. So first of all, is it linear? No. Okay. As soon as you get two different sets of numbers, it cannot. As soon as you get two different numbers here, it can't be linear. Now we need to do one more to tell whether it's quadratic or not. So We're saying negative 405 minus negative 135. Okay, so again, see what I did? I subtracted these numbers, I subtracted these numbers, now I'm going to subtract these numbers. And what did I get? Negative 270. Okay, now we need to tell, hey, is this, and now is this quadratic? Is this quadratic or is this exponential? Okay, so again, quadratic or is it exponential? Okay, and now we have to repeat that same process again. So this is the reason we had to do this twice. We need some numbers to compare here. So again, what do we got? Let's do negative 90 minus negative 30. That's going to give me, this is a change of negative 60. And if I do it here, again, you guys should be able to tell that it's not. Negative 270 minus negative 90. Okay, and that's negative 180. Since this secondary set of numbers is not constant, it is not quadratic. This is an exponential function. Okay? A quick little bit of a trick. If you take a look at these numbers, these numbers are sinking very fast, right? This is a big change, then a bigger change, then a bigger change, and a bigger change. Now, both quadratics and exponentials are going to change rapidly, but exponentials typically change more rapidly. So again, if it's something you can see, if you see huge drops in numbers, it's probably going to be exponential. So if you have to guess, do that. But if not, actually take the time to do the work, okay? All right, so here, what do I got to change? Again, from 9 to 27, I'm not going to do all these with a calculator, but again, so again, what's 27 minus 9? You guys know that. You guys know your times tables. That's going to be 18. 18 minus 27. I'll do both of them. 81 minus 27. 81 minus 27 is going to be 54, and 243 minus 81. So you get 54 and 162. 54 and 162. So definitely not linear. Okay. Now is it quadratic or exponential? Okay, now again, now we have to take a look at these secondary numbers. What's my difference here and what's my difference here? Well, again, we've got 54 minus 18. That's going to be a difference of 36. And 162 minus 54, what's your difference going to be? 108. So 36 and 108. So again, definitely not quadratic. So this one again is going to be exponential. Okay. This one, every once in a while, they're nice to you. They give you a layup. What's your change here? Negative 1, right? These numbers are going down by 1. Since these numbers are all going down by 1, this is going to be linear. Okay, constant change. They're all going down by 1. Okay, here, oh my God, they threw in decimals. It's fine. You have a calculator. 72.5 minus 46.4. It's going to give you 26.1. Sorry, housekeeping. Okay, over here again, what's one screen that? What's 104? 104 minus 72.5, 31.9. What's the difference here? 31.9. So again, nonlinear, right? First of all, nonlinear. And again, over here, what do we got? We got 142.1 minus 104.4, and that's going to give you 37.7. Okay, so linear is out. Now we want to is it quadratic. Okay, so again, now I have to take the differences between these numbers. Okay, so what are we going to say? I'm going to say 31.9 minus 26.1. I'm going to say 37.7 minus 31.9. So if you take a look over here, both of these answers gave us 5.8, right? So this is a difference of 5.8, and this is a difference of 5.8. Since that number is the same, we're going to go ahead and say this is quadratic. Okay? And the last, most difficult one that they gave you, and I don't know why they do this to you guys, is they give you guys all these crazy fractions. Put them in your calculator, guys. I put in my calculator, okay? So again, what's 7 over 2 minus 7 over 2 minus 7 over 3. What did I get? 1.6 repeating. Okay, next one's going to be what? 21 divided by 4 minus 7 over 2. By the way, I don't care what Excel says. If you can do these, that's fine. If you get stuck on these, I'm not all that concerned about the decimals, yes. Fractions, this is busy work, I think, to a certain extent. 63 over 8 minus 21 over 4. Okay, what's that going to be? 2.65. Okay, so right off the bat, not linear. Okay, it's not linear, right? These are different numbers. Now we have to check these. So I'm going to say 1.75 minus 1 point, and then just go ahead and just put a bunch of sixes in your calculator. Okay, and it should give you, what's this a difference of? 0.0833 repeating. Okay, and here, again, what do we got? 2.625 minus 1.75, and it's going to give you 0.875. So again, this is going to be exponential. Okay, so again, give those a try. Let me know if you guys have problems. Like I said, check the first round, see if it's linear, then check the second round and see if it's quadratic.